Today's lesson is specifically on the quadratic formula, which is amazing. You're going to love it, right? You should already know the quadratic formula from Algebra 1. But before jumping into the quadratic formula, I do want to go over these three problems, these three simplifying problems, because when you do apply the quadratic formula, most of the time we get to this like final couple of steps and students can't get from here to the final answer. Okay, so let me actually move these just so I could have space and work on one of these at a time. Let's look at number 1 here. Whenever you have a square root, if you could simplify it, you better simplify it. So the square root of 12, right here on the side, it's not a perfect square number. You want to break it down with multiplication to get a perfect square number. That'll be 4 times 3. That way when you split the root, you'll have 2 square root of 3. So we are just going to replace that square root of 12 with the with 2 square root of 3 because it's the same value. It's just simplified. So let's rewrite it. 8 plus or minus 2 square root of 3, and it is over 4. Okay. Now at this point, if you have something plus or minus something else divided by something, you could technically reduce all 3 terms at once. All right. So it's kind of like this. If I had a, don't copy this down, but if I had a 2 plus 6 divided by 2, you could just say, I mean, what's the answer right there? This is what? That's 8. Oh, it's 8 divided by 2? The answer is 4, right? But you could say, oh, I'm going to take this 2 and that 6 and that 2 and reduce them all by 2. So you could say, convert that. Divided by 2, you get a 1. Divided by 2, you get a 3. Divided by 2, you get a 1. So you really just end up with the 1 plus 3 over 1, which is 4. Okay, so what I'm trying to say here is when you have 3 terms, you could reduce all of them by 2, and that's what we're going to be doing. So let's reduce all of them by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. You could cancel it out. You could put the 1. You don't have to. 4 divided by 2 is 2. So what we have here is 4 plus or minus 1 square root of 3 over 2. That's the final answer. Okay? Bless you. You don't even have to put that 1 in front of the square root of 3. It's kind of like if it were x, you don't have to put a 1 in front of x. You could just say x. Right here, you don't have to put the 1. You could if you want to. But anyways, that's your answer. And again, on the quadratic formula, you're going to end up with these situations where students get stuck on this part, getting to this final simplified part. Let's practice a couple more times. Number 2 right here. Okay, so let's simplify that square root of 8. What could I rewrite square root of 8 as? 4 times 2. Always put the perfect square number first. That way when you split it, you could actually do the square root of 4, which is 2, and the square root of 2 is going to stay the square root of 2. So I'm going to replace this square root of 8 with its value, 2 square root of 2. So I have 2 plus or minus 2 square root of 2 all over 2. So what's my final answer going to be? What happens with this 2, that 2, and that 2? They all cancel out. So this becomes 1, this becomes 1, this becomes 1, right? So what's your final answer going to be? You're not going to, I mean, you could write it like this. Well, I'm sorry, over 1, but that's kind of ridiculous, right? So what's the final answer going to be? It's just going to be 1 plus or minus the square root of 2. And again, I'm just practicing the final step that you're going to have to be doing when we apply the quadratic formula. Let's try the third one. So I need to simplify the square root of 32. What do I rewrite that as? 4 times 8? 16 times 2, right? Use the highest perfect square number possible. So when you square root it, you'll have the answer 4 with the square root of 2. So let's replace the square root of 32 with that 4 square root of 2. So we have 8 plus or minus 4 square root of 2 over 6. What am I going to reduce this entire fraction by? 2. By 2. So if I reduce the 6 by 2, I'll have a 3. If I divide 8 by 2, I'll have a 4. If I divide 4 by 2, I'll have a 2. So there's my answer, 4 plus or minus 2 square root of 2 over 3. Yay?
Also, you can divide it by different numbers, no matter what it is.
Yeah, if you're able to, right? So like if this would have been a 5, like a 5, a 4, and a 6, then you can't do anything to it. You would just leave it like that as your final answer. So I guess my point on these 3 problems is students, when they get to this part of their answer, they mess up on the reducing part, or they forget to reduce. If it were a multiple choice test, this is the correct answer, but on the multiple choice test, you're going to have this. So if you don't know how to get from here to here, you're not going to be able to select the right answer on the multiple choice test. And that's what the final exam is, all right? Oh yeah, one other detail, guys. If for some reason this would have been a negative 32, right? If it would have been a negative 32, I'd have an I involved, which would mean that there'd be an I right here. So like let's say you did do this whole problem and you have 4 plus or minus, but let's say you had a 2I square root of 2 over 3. Then you'd have to separate this fraction. Remember, you can't leave it as one item. Because there's an I, you have to separate the real from the imaginary. So you have to put the 3 on each of them and separate them. Just remember that. We've already done that in the past. If you have an I involved, you have to separate them. Okay? But we don't have an I involved on this one, so don't worry about it. Anyway, let's get to the actual lesson. Section 4.6 is the quadratic formula. We should already know the quadratic formula from Algebra 1. You have to memorize it, right? But before we even talk about the quadratic formula, what do we have here? We have a Swiss Army knife. And it's kind of like, that reminds me of the quadratic formula, because the quadratic formula always works on any quadratic equation, all right? So far we've developed many different tools to solve equations, to factor, right? We have factored GCF on equations and then we split it and solve, right? That's one method. That's a tool that we know. We know that if our A value is 1 in a quadratic trinomial equation, you set it up, parentheses, and you simply think what times what is C, that if you combine together is B, that way you could factor it, that way you could split it and solve. That's another tool that we have in our belt, in our tool belt. We also learned about completing the square, right? That's another tool in our tool belt. And we have, like let's say if your A value, if your A value is not 1, then you have to do that multi-step process. Step 1 is multiply A times C. Step 2, make a list. Those are all different tools that we have so we could factor quadratic equations, so we could split them and solve, right? So the quadratic formula will always work, right? So that's why I have a Swiss Army knife right here, because it reminds me of the quadratic formula. It doesn't matter if you need to cut a piece of paper, or if you need to cut something, or have a saw right here. You have you want to open up a bottle. There's a bottle opener. There's everything in a Swiss Army knife. So the quadratic formula will work on any type of quadratic equation, whether it's factorable or not factorable, whether the A value is 1 or 5 or 3. The quadratic formula will always work. Okay, so let's say you completely forgot about all other factoring methods, and I tell you to solve a quadratic equation, and you forget everything. If you remember the quadratic formula, you'll be able to solve it with the quadratic formula. So what is the quadratic formula? It's x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's right. I have it memorized. I don't even think about it. It's just like breathing. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Whatever. In Spanish, x igual a negativo b más o menos raíz cuadrada de b cuadrado menos 4ac dividido por 2a. It's like breathing. It's like breathing, right? I have it memorized. I don't even think about it. It just comes out, right? That's what you guys need to do. You need to have this quadratic formula memorized. Okay, so please write it down somewhere in your notes. Quadratic formula. I know most of us already have this memorized. It's something that you should have done to pass Algebra 1, but maybe it's been a couple of years since Algebra 1, so you're a little rusty. Let's rewrite it. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Now, in order to use the quadratic formula, you have to have your standard form quadratic trinomial equation equal to 0, right? Okay, so if you don't have your equation equal to 0, rewrite it, make it equal 0. That way you could safely identify your A value, your B value, and your C value, which are just numbers. And those numbers go into the A, the B's, and the C of your quadratic formula, okay? So once you've already copied down the quadratic formula, I would also copy this down. That's just the quadratic formula without the letters with parentheses. Because whenever you want to plug in values, the safest thing to do is to replace your letters with parentheses and then plug in your actual values, okay? So on every single problem that you do, on every single quadratic equation that you solve using the quadratic formula, I want to see parentheses. That way you could identify A, B, and C and just plug in your B right there and right there, your A right here, your C right there, and your A down there. You will not make any mistakes if you set this up every single time. All right. So before we actually start applying the quadratic formula, I put this in red because this is a special variable expression. B squared minus 4AC, that's called the discriminant. Okay? So if you want, go ahead and I don't know, circle, underline, and then draw an arrow and label it. That's called the discriminant. Okay, the discriminant. As a matter of fact, let's take down some good notes on the discriminant. So you've already copied down the quadratic formula. Now let's talk about the discriminant. What is the discriminant? It's the value inside the square root of the quadratic formula. Okay, I didn't put of the quadratic formula, but you know, it's the value inside the square root of the quadratic formula. Okay, it's the b squared minus 4ac. Now let's think about this, because you guys are going to have to memorize these facts as well, but you don't actually have to memorize it if you understand math. Why is that? Well, if I did the math right here, if I did b squared minus 4ac, let's say I ended up with a value, a number that's positive, like 9, right? Then you'd have the square root of 9, yeah? Which would mean that you'd be able to do the square root of 9, which is 3. So you'd be able to add and subtract 3, which would produce two different answers. So if your discriminant is positive, you will get two answers, which means that you will have two x-intercepts, two real roots, two real solutions, whatever you want to call it. But if the discriminant is positive, you will have two answers. What if your discriminant right here was 0? Think about that, guys. Everybody, stop what you're doing and just pay attention to what I'm saying right now. If this were 0, what's the square root of 0? 0. Would you have different answers if you add 0 and then subtract 0? No, you get just one answer, right? So adding and subtracting 0 is only going to produce one answer, as opposed to like adding and subtracting the number 3, right? That would produce two answers, right? So the discriminant value, if it's positive, you'll have the square root of a positive number, which will ultimately produce two real answers. If your discriminant is 0, you're only going to have one real answer. If your discriminant, when you do the math, b squared minus 4ac, if that's negative, could you do the square root of a negative? Yeah, but you end up with imaginary, which means that you don't end up with real answers, you end up with imaginary answers. Okay, and that's exactly what these notes say right here. If your discriminant is less than 0, oh, by the way, there's a typo. Let's do this. Less than 0, equal to 0. This one should be greater than 0. I apologize. Greater than 0. Sorry, if you already copied down those notes, you have to change that to a greater than 0. So if your discriminant is less than 0, which means negative, then of course, if this is negative, you're going to end up with imaginary answers. That means that there's no real solutions. That means that there's no real answers, no real roots, no real x-intercepts. All right? If your discriminant is equal to 0, if this value right here is equal to 0, it doesn't matter if you take the square root of 0 and add 0 or subtract 0, you're only going to get one real answer. If your discriminant is greater than 0, if it's positive, you're going to end up with two real answers. Okay? Now, let's just take one more moment and talk about what that looks like visually. If this discriminant were less than 0, if it were negative, how many answers do I get? If it were negative, how many answers do I get? No real answers. I get two imaginary answers, right? Okay, if it were negative, you can't do the square root of a negative, you end up with an imaginary answer. So visually, what that would mean, if you were to graph the parabola, that would mean that your parabola never crosses the x-axis. It does not have real x-intercepts. Remember, x-intercepts are the same thing as solutions, same thing as answers. Okay? So if your discriminant is negative, then you have no real answers. That would mean that it does not cross the x-axis. How about this next one? If the discriminant is equal to 0, then you're going to have one real answer. What would that look like visually? It only touches at one spot. So maybe your parabola's just touching and then it comes back up, right? Or maybe touching but opening down. But yeah, that would mean one real answer right there. It just touches the x-axis at one spot. The other one, if your discriminant is greater than 0, well, that means it's positive. So if this is positive, yeah, you will have two different answers, because if you add that positive number or you subtract that positive number, you're going to end up with two different answers, which means that it will cross at two different locations. So your parabola would be something like that, crossing at two different locations. Two x-intercepts, two real answers. I'm just trying to link everything, guys. So I haven't even started applying the quadratic formula. Let's start doing that. Just remember the inside value, the b squared minus 4ac, that's called the discriminant, and it will tell you a lot. It tells you if your parabola crosses once, crosses twice, or not crosses at all, right? That's the same thing as having one real answer, two real answers, or no real answers. Here we go. Like I said, the quadratic formula is a tool that works every single time, right? However, like this knife right here, it's awesome because it'll work for anything. You want to cut some paper, it'll work. You want to open up a bottle, it'll work. You want to measure something, there's, you know, it'll work, right? But the bottom line is, if you wanted to screw something in, is it going to be really easy to screw something in with this screwdriver? Nah, right? I mean, it'll work, but it's not the best tool to use. So the quadratic formula, it works, and I love the quadratic formula because it'll always work no matter what. You could always just decide to use the quadratic formula. But is it the best tool for this problem? What would be your better tool for this problem? The GCF, right? Yeah, that way you could apply the zero product property. So let's pull out the GCF. What would you pull out? What would be left? 7x minus 5. And that is equal to 0. So now you could use the zero product property. If you have something times something and it equals 0, then the first something could be equal to 0, and the second something could be equal to 0, right? And then you solve both of them. This one's already solved for you. The answer is 0. The other one, if you add 5 to both sides and then divide by 7 on both, you will get a positive 5 divided by 7. That'd be your answer. So those are your two answers. Super easy, way easier than using the quadratic formula, okay? So let me actually write that down right here. X equals 0, x equals 5/7, okay? But I do want to prove that the quadratic formula will always work, okay? So how about you guys identify A, B, and C and actually use the quadratic formula to get those same exact answers. We already have the answers. It's 0 and 5/7. But let's use the quadratic formula to be able to find these exact answers. Now, in order to apply this quadratic formula, what's your first step? What do I recommend? Parentheses. Okay? Now, let's identify A, B, and C. What's our A value here? 7. What's our B value?
5.
-5. And what's our C value? There's nothing here. We need a C value there, so we're going to say that the C value is 0, right? Okay, which should belong on the left side of the equal sign. Anyway, so let's plug in our B's. What's our B value? -5. So you put a -5 right there and a -5 right there. What's the A value? The A value is 7. Let's put a 7 right there and a 7 down there. And what's our C value?
0.
We said 0. Okay, so let's put the C value of 0 right there. Now, we always begin solving the quadratic formula with the discriminant itself, okay? What's the discriminant again? Yeah, the value inside the square root, the b squared minus 4ac. So let's begin with b squared minus 4ac. What do I do first? Do I do exponent, subtraction, or multiplication? Exponent. So let's do -5 squared. What's that? 25. So let me put a 25 right here. And then what do I do next? Do I subtract or multiply? Okay, what's 4 times 7? Times 0. Okay, so I really have a 25 minus 0, right? As my discriminant value, which is the value inside the square root. I might as well do 25 minus 0. What is 25 minus 0? 25. Okay, so let me rewrite my whole thing. I have a plus 5. I have a positive 5 plus or minus the square root of 25 divided by what? 14. Might as well do the 2 times 7, get a 14. Now, our discriminant value is positive, which means how many real answers am I going to get? I'm going to get 2 real answers, right? I don't know what they are yet, but I am going to get 2 real answers. If this would have been a negative 25, I'd have no real answers because I'd get imaginary answers. If this discriminant would have been 0, then I'd only have 1 answer, which would be the answer 5/14. Right? If this would have been 0, the square root of 0 is 0. And it doesn't matter if you add 5 with 0 or 5 minus 0, you still get 5/14. So you'd only get 1 answer if your discriminant was 0. Anyway, let's do the square root of 25. We get 5. So we really have 5 plus or minus 5/14. That's really 2 answers. 5 plus 5/14 and 5 minus 5/14. 5 plus 5 is 10. 10/14, you can't divide it, but you could reduce. What does it reduce down to? Divide by 2, 5/7. Perfect. On the bottom we have 5 take away 5 is 0. 0/14. What's 0 divided by anything? 0. So we get our 2 answers, 5/7 and 0. Do you guys see how we had the answer 0 up here and 5/7? It's the same thing, it's just a different way. So the quadratic formula will work on any quadratic equation, Doesn't matter how easy it looks or how hard it looks. If you have decimals, you have fractions, the quadratic formula will always work, okay? But then again, the first method was easier. So sometimes you could identify clearly which tool is easier to use. So how about this? This guy right here. What's the first thing you should do? Move the 3. Okay, so let's do that. Everybody copy it down, please. Move the 3 over. You're going to have x squared minus 6x plus 3 equals 0. All right, so which tool should I use? Quadratic formula?
No, you can use the...
I mean, my first reaction, my first reaction would be use the parentheses with the x, right? Yeah. And start thinking, what times what is 3? That if I combine together is -6. Uh-oh. It doesn't work. Right? So even that's great, though, that we tried it, because if you have your a value of 1 and it's a quadratic trinomial, you might as well try this. It only takes a couple of seconds. Because if it works, you just split them and solve, and it's really easy. But right here, we saw that it's not factorable. So the beauty of the quadratic formula is even when they're not factorable, the quadratic formula will get you the answers. So the quadratic formula always works every single time. You have all these different tools, but sometimes those tools don't work. This particular tool will always work. So let's use the quadratic formula once again. Quadratic formula is x equals -b plus or minus square root of b squared minus 4ac divided by 2a. Let's keep that right there on the side. You need to always start with parentheses. Let's identify our a value is 1, our b value is -6, our c value is 3. So let's plug in our b value of -6 right into the b positions. The a value of 1 right there and down there, and the c value of 3 right there. And now we could begin with the discriminant. So what is -6 squared? 36. And what is -4 times 1? That's -4. And what's -4 times 3? -12. So my discriminant value so far is 36 take away 12. And what is 36 take away 12? 24, right? So my value inside my discriminant is 24. So let me rewrite this whole thing. So far I have a +6. Why positive? Because the negative and the negative become positive. Plus or minus, the square root, we said we end up with a 24 in here. Over what? 2. Over 2. So this is where that class opener comes into play. Are we able to simplify this answer? This is the correct answer right here. Yes. X equals that, but I need to be able to simplify it. So let's simplify. What is the, on the side, what's the square root of 24? It breaks down to what? Are you going to break it down to 12 times 2? No. 4 times 6. Split the root. That way you end up with 2 square root of 6, right? So let's replace the square root of 24 with 2 square root of 6. So our next part of our answer, or our answer, is going to look like this now. 6 plus or minus. We said we replace it with 2 square root of 6, all divided by 2. So our final step here would be to do what? Reduce all 3 terms by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. 2 divided by 2 is 1. So what's our final answer going to be? 3 plus or minus square root of 6, done. 3 plus or minus square root of 6, done. You don't need to put it over 1. That'd be ridiculous. You don't have to put it over 1.
You have to put x equals or not?
Yeah, technically it's x equals, right? Technically it's x equals. And this is two different answers. By the way, if you had a calculator, you could actually do 3 plus square root of 6, which is a crazy decimal, but it'll give you an answer that's a crazy decimal. And that location will be where your parabola that opens up, because the a value is 1, that's where it would cross the x-axis. And then if you did 3 minus that crazy decimal, you get a crazy decimal as an answer, and that is the location of where it would cross your x-axis as well. So by knowing that the discriminant is positive, we end up with 2 answers. Even though they're crazy decimals, we still end up with 2 answers, 2 x-intercepts. All right, how about this guy? Should I use the quadratic formula? What easier method would you use? What other tool could do this better? You could move it to one side, set it equal to 0, pull out a GCF, or you could just start solving by getting rid of things by dividing by 3. Just like Victor said, divide. We end up with x squared equaling, I think that's divisible by 3. I think that's negative 18. So then I'd get rid of the square by doing what? Square root, x equals plus or minus, because we applied a square root. Now, what is the square root of negative 18? Could I break that down? 9 times 2, yeah. And don't forget about the negative. That comes out as an I, right? So this negative should come out as an I. So we really have I on the outside times square root of 9 times 2. That's really I times 3 times square root of 2. Put it in order, 3I square root of 2. So x equals plus or minus 3I square root of 2. I think that's a heck of a lot easier than doing the quadratic formula. But if you did want to use a quadratic formula, you just move this over. That would be your C value of positive 54. Your A value is 3. Your B value is 0. Plug it into the quadratic formula. Do the math. You should end up with that same exact answer anyway. Okay? How about this guy? Would you use the quadratic formula on this one? I would. You know why? The A value is 4. So our only other option would be to say, oh, A times C, and then get a huge number, and then think of the multiples of that huge number that combine together to give you B. Not only that, it might not even be factorable. So anytime you have a quadratic trinomial and you have a number out here, I would use a quadratic formula. I wouldn't even try to factor it, okay? So let's use a quadratic formula. Quadratic formula, always start it with parentheses. Identify your A, B, and C value. Your A is 4, your B is negative 4, your C is 17. So you put a negative 4 right here into the B spot, negative 4 right there into the B spot. The A is positive 4, put it right there in the A spot, and also down there in the A position. And the C value is 17. Of course, you could use calculators, and I'm going to ask you to help me out with the calculator right now. Starting with the discriminant, we're going to go negative 4 squared. That's positive 16. Let me just write that down somewhere. And then what is 4 times 4? That's 16. What's 16 times 17? It's negative 2. Help me out, somebody, calculator. 16 times 17. 272? Perfect. All right, so our discriminant value, what is 16 take away 272? I think it's 256, right? No, because the negative 4 times itself, negative 4 times negative 4, positive 16. Right? When you have something squared, multiply that with itself. Negative 4 times negative 4, positive 16. Over here, yeah, negative 4 times positive 4 times negative, that gives you a negative 272. So our discriminant value is negative 256. That's inside the square root. Are you with me? Okay, so let's rewrite this whole thing. Instead of minus 4, I'm going to put plus 4. Then the plus or minus, and then the square root of my discriminant value is negative 256. And it's going to be divided by 8. So based on the discriminant value, would the original parabola, I know I'm asking too much here, but the original parabola would it cross the x-axis one time, two times, or it will not cross the x-axis at all, based on the discriminant value?
Oh no.
It's not going to cross at all, right? This is a parabola that opens up that's pretty narrow. It's vertically stretched by 4, but it will not cross the x-axis. How do I know that? Because my discriminant is negative, and when you take the square root of a negative, you end up with what? I, imaginaries. So you're not going to end up with real answers. It's not going to cross the x-axis. Anyways, I'm just trying to link everything. Anyways, what is the square root of negative 256? I have 4 plus or minus. What's the square root of 256? Anybody? Calculator? 16. So the negative would mean that you have a 16i, correct? And it's still over 8. So what could I do here? Or what should I do here? Yeah, I would reduce everything by 4, right? But you know what? Because we have an I involved, we can't just reduce it and leave it as a fraction. You're going to have to separate it anyway. So we might as well separate each of these by the divisor 8. So we're going to rewrite this as 4 over 8 plus or minus 16 over 8 with the I on the second one. So our final answer, x equals 4 over 8 reduces down to 1/2 plus or minus 16 divided by 8 is 2 with an I. So again, this is the correct answer, but it's not reduced. And even reducing it wouldn't cut it, because when you have an I, you want to separate your real from your I's. Complex number, real, imaginary. So we have to separate that 8 to the 4 and to the 16, and then divide each one of them, and that's your final answer right there. So the quadratic formula always works. It always works. What's the first thing to do on this one?
Move the 40.
Move the 40. Move the 40. Rewrite x squared minus 3x minus 40 equals 0. Would you like to use the quadratic formula on this one? Why not?
X equals.
The x squared doesn't have a number in front of it, which means maybe, and you might as well try it, maybe you could find out what times what is c that if you combine together is b. So if you need to, make a list. How could you get negative 40? Negative 1 times 40. Negative 2 times 20. Negative 3 doesn't work. Negative 4 times 10. Negative 5 times 8. That's about it. Which pair of numbers combines together to give you the middle value, negative 3? Negative 5 and 8, but we need to change the signs. That's right, because right here, negative 5 plus 8 is 3, and we want it to be a negative 3. So let's change the signs. So it's going to go in as a positive 5 and a negative 8, and it is equal to 0, which means that we're going to split them and solve. X plus 5 equals 0. X minus 8 equals 0. You're going to get two answers. X equals negative 5 is one of them. X equals positive 8 is the other one. Okay. So we found our answers to this quadratic trinomial equation by factoring, splitting, and solving. So that was the better tool. If I wanted to, I could have used the quadratic formula and it'd give me the same exact answers, right? So you have a bunch of tools. The quadratic formula always works. If you want to throw all the other tools away, you could. You could throw them all away and just use the quadratic formula every single time. I wouldn't do that because this one's pretty easy, just factoring, splitting, and solving, right? So always look at your problem and decide which is the best tool to use.